solution that can measure any object, you may well end up with two approaches being used to deduce from data.
The most important thing is the brain power of the operator. If you don't plan, you'll end up with a mess. Who do you work for, by the way? Sorry.
Phase Vision. We are a supplier of structured light scanners.
I apologise. Your name wasn't listed, so it would be fair to say that there's a big swing towards non-contact systems over the last 5 years. As I said, that contact is disappearing, but non-contact is starting to get features it didn't have in the past. Passive vision and photogrammetry is another system used where we take digital images from two different perspectives and we can align that data to generate an image you can rotate. And you can actually do this relatively cheaply. There's a piece of software on the internet which you can download. You can take two digital images of, say, a cup, process the data, and then show the cup rotating in space for the cost of a digital camera. I have to say there's digital cameras and digital cameras. When we talk about high quality photogrammetry systems, the cameras are tens of thousands of pounds. Correct? Do you sell photogrammetry systems? Garmin is the big player in this system because they sell both the Atos system, which is a structured light system, and they also have the Tropos system, which is the photogrammetry system. The two are worked together, so you can actually scan something the size of the QE2 if you wanted to do. You can effectively scan very large objects, and certainly aircraft and things they've done in the past. The advantage with photogrammetry is non-contact, a big area covered by each scan. Again, it's field of view, so the number of pixels of the area capturing affects the ultra resolution, but up to 1 million points a second. So now you have this issue about how to store and manipulate that data. Very portable, you can wheel them out to an aircraft and put a few targets on it. You need the targets because you'll need to join up the individual photographs otherwise you won't have any data. And again, there's line of sight limitations, but again, with two cameras, they're reduced. Finally, talk about hybrid systems, because there are problems with both contact and non-contact. And if you can combine the two, sometimes you can actually get the best of both worlds. And there's a system, a couple of people sell systems, including this Prescient company, that actually have LED target tracking. So it's a contact system which you press against the object and then you capture optically where it is. And you can do a lot of these things with articulated arms. But I can imagine there's certain applications where you don't want to pull an articulated arm into that area in case you cause damage. So it's a neat system, but you don't have the optical properties of the object to consider because you've got a bespoke target.
It's worth noting that they put these systems now with laser scans on the end.
Yeah, in fact.
No, I mean the.
Oh, do they? Right, sorry.
The optical systems.
So these optical systems, I've been told by Chris, also have laser scanning systems as well. So how do they do? How do the two work together?
They use the rigid body by the probe at the top, and they track the laser and send it to an arm.
Yeah. Okay, I can see now. So to overcome the problem with a handheld scanner, effectively. So it's one way of monitoring where your arm is and your scanner is in space. That allows you to use a handheld optical scanner, but you're actually monitoring its location remotely from somewhere else. Thank you for that. I'm not advertising for Metris, it's just that it's the easiest one I could download, the Faro website. The images are too big for me to download at home. And what you'll see here is, you can, is a touch trigger and also a laser together. You get the advantage of both worlds. You can take precise datum points using the touch trigger and you can then sweep the arm around. And it allows you to then register all the information more precisely. We'll quickly go through the RE process flow, which starts with preparation, scanning, and post-processing. Preparation is important. It's like DIY, like painting the door at home. You know, just slap the paint on and all the paint drops off. Or you can prepare properly. And the first thing is think about what you want to capture. What do you want to capture the whole object or just some areas of interest? And what is the detail you want? Because in some areas you might want less coverage than others. You also need to think about what you want to use the data for. Because if you're going to then degrade the data later on, why bother capturing to 0.1 resolution when you're going to be using a 1mm downstream process? It's very important to remove dust and debris and repair damage, to fill in holes, and also you might have to apply a coating to allow optical scanning to be undertaken most successfully. We're involved in a project with a company where we're scanning a wax-coated model. So we sort of laid up wax onto a master pattern, and then they scanned it. But somewhere along the line, someone actually put a coffee cup on the wax, and it left a stain. And then they actually scanned the data, and they machined from it. And every plastic moulding, when you held it to the eye, you could see this coffee stain. So it's that sort of thing we're trying to avoid. That is not a good result. Another thing to do is select the scan orientation. Can you get into the feature you want? Does the arm reach? A number of times you start a job off, and you find halfway through the process, particularly the arm can't get round the back to get the data. So you need to practice a little bit, do a bit of preparation. And of course, parts will need to be held down, but without distortion. The scanning is probably the easiest thing. Be careful what I say here, but if you do your job right, the scanning should be fairly uneventful. The post-processing is still a battle. Okay. The first thing we can do is take the cloud point data and polygonize it. So we can put a triangles through it and we can structure it in some way. We can take those sections. We might have to scan an object in 3 different locations, and we need to marry up that information. So we'll combine the scans, we'll align the data sets, and then we'll remove any redundant data. We then may have to reprocess again if the data is not in the right format for our prototyping, for finite element analysis, and machining. This is relatively painless, so from 1 to 4, it could be a couple of hours. When we get to 5, it's a whole different ballgame. A number of people come to me and said, I've scanned the object, where's my CAD data? It doesn't work that way. To create the CAD data, you have to surface the data you've got, which is effectively can be as much work as to redesign from scratch in CAD. Anyone want to argue that? Okay, it can be very expensive. So when you say to a client, it's £500 to scan and £5,000 to generate the CAD data, it can be a little bit problematic. So the software is improving, and we're going to have some demonstrations of the latest software, demonstrations of Geomagic, Delcam, CopyCAD, also through Matic for Materialize. But the push-button operation still doesn't exist. When someone comes up with the software that does it and outputs a wonderful file, and all you do is to select ProEngineer, SolidWorks, Delcam, PowerShape, they'll make $1 million, because that's what the industry really wants. It doesn't exist, does it? No. Here's some case studies. Chris might remember these because he was involved in the scanning work. This is a structured light scanning project we did with a chap who'd been involved in a car accident in his early teens. And then as he got to grow older, he got more self-conscious of this scarring. And so we, together with a surgeon, a plastic surgeon, worked on a project to try and generate a stencil through which the surgeon could operate and carefully reset this tissue to generate a perfect result, following something called the Langer lines, which are, when you screw your face up, grimace, you get creases. They're the Langer lines, and a good plastic surgeon will hide any cuts parallel to those Langer lines. Here's the guy being scanned. It's a simple relatively simple piece of kit, portable piece of kit.